Today we're going to talk about not molar mass, but a mole. So what is a mole? We are looking at a mole of particles, or an amount, a lump, a group. And Avogadro decided that this was 6.02 times 10 to the 23rd. This program doesn't really like doing that, so it's really written as 6.02 times 10 to the 23rd particles. So 1 mole means 6.02 times 10 to the 23rd particles. How much is that? So, if we look at a sheet of papers, a mole of sheet of papers, how much would that be? Okay, so if we know a ream is 500 sheets and it's also 5 centimeters, we can do a little conversion action. So we have 1 mole, which mole is 6.02 times 10 to the 23rd sheets. And 500 sheets is 5 centimeters. Let's get this into meters. So 100 centimeters is 1 meter. Do the math out. You get 6.02 times 10 to the 19th meters. That's a pretty large number, so let's convert that to kilometers. It would be 60.2 quadrillion kilometers tall. So a stack of papers up would be 60.2 quadrillion kilometers tall. Okay, seriously, what is 60 quadrillion kilometers? Let's look at some standards that we know. The Sears Tower in Chicago, which is not named the Sears Tower anymore, is only 0.4 of a kilometer. Dubai, Burj in Dubai, which may not be the tallest building anymore, but it's pretty darn tall. It's almost a kilometer high on its own. Mount Everest is almost 9 kilometers. Going all the way to the moon is 3.83 times 10 to the 5th. So this should be 10 to the 5th kilometers. To the sun is 10 to the 8th. We still need to get 10 to the 16th kilometers, and all the way to the sun is to the 8th. To the moon, or from the sun to Pluto, which is at its farthest point, is 10 to the 9th. So still, if we started a stack of paper here on Earth and stacked a mole on top, we would be going past Pluto almost double that. But let's look at it in terms of the moon. If we looked at it in terms of the moon, our round trip would be 1.2 times 10 to the 10th. So we kind of have that situated here. So if we do this math, we would take 5 million round trips. So you would have 5 million times would you go from the Earth up to the moon and back 5 million times. So basically, we would have 10 million stacks of paper, because you've got the stack going up, and then the stack coming back, and then the stack going up, and then the stack coming back. So 10 million stacks. This takes up the space of 135.3 football fields. So quite a bit of space is taken up by this mole of paper. And this is 135.3 football fields going from the Earth to the moon. Okay, so I'd like some estimates on water, and in class we kind of were looking at the ocean or size of the moon. Some people suggested more like Lake Michigan. Some people were even a little bit smaller, and we're asking about, or we're making estimates like a pot of water on the stove. Yeah. But the real answer would be that much. Around 18 milliliters contains a mole of particles. That's how tiny a particle is. Crazy. 18. In paper, which is pretty skinny as it is, paper, it's pretty thin, takes 10 million stacks going from the Earth to the moon and covers a span of 135 football fields of going from the Earth to the moon. And in water, it's only 18 milliliters. Pretty tiny stuff.